Okay, I'm going to go over the first few steps of how to clean up a data set. Part one, renaming the variables. There are two views. One is the data view, where each row represents a participant survey. In the variable view, which is where we're going to look, each row represents each variable. When you first get it from Qualtrics, it'll just have V1 through whatever, and you want to go through and just kind of create logical names for each variable. So if you send it to someone else, they can kind of figure out what's going on. A little quick shortcut is if you go to Excel, you can, instead of having to retype every single variable, if you enter in a name and drag, that's a lot quicker way to write it, so you can copy and paste that over back into Excel. Part two, what we want to do is check the reliability and recode each scale. So what we're working towards is, instead of having 10 separate items for religious commitment, what we really want is one variable that sums all of these up or takes a mean of all 10. But before we do that, we need to make sure that we've reverse coded any items that are kind of different than a different direction than the others in terms of their meaning. So an example is, I have so much to be thankful for versus 3. When I look at the world, I don't see much to be grateful for. So here's how you do that. Scale, reliability. You pick the items that you want from over here. So let's take the religious commitment ones. Click these options, descriptives, and we're also going to look at the item-item correlations. And then hit paste, which gives you your syntax. Syntax is a quick way to rerun your analyses later, and it tends to be the quickest way to even write new commands. So if I was doing this, I would get this initial syntax, and then for the rest of the data set, I would copy and paste this command, and then add each of my new sets of variables right here. So to show you an example with just one, with gratitude, I'd copy and paste those items here. Oh boy, I don't know what it's doing, so I'm just going to type it. Okay, so to play that, you just highlight what you want to run and hit play. And okay, reliability for religious commitment looks very good. You want to see it certainly above 0.70, and higher is generally better. So this indicates that there's about 7% error. If it was 0.70, it'd be about 30% error. So you generally want to reduce error. The main exception would be sometimes researchers will try to get an efficient scale. They'll balance efficiency with lower error. And so the more items that you have, like this one only has 10, but if we had 50 items, then the alpha would be even higher, all things being equal. And you might drop some items and say, we don't need 50 because 10 does pretty good. Okay. So if you check the item-item correlations, if there are any negatives here, it indicates you might have a problem with reverse coding. Item total correlations, any negatives would indicate a problem, but we're good. Okay, here's what it looks like if there's a problem. Oh boy, alpha's terrible. That's not even close to 0.7. If we look at the item, oh boy, that's a negative. That's not what we wanted to see, but it makes sense because this item's worded in the opposite direction. Same thing for 6. Oh boy, this confirms what we were thinking. This particular item's negatively related to the total score. Same here. So what we need to do is recode recode into the same variables. And what we want to recode, what did we say? 3 and 6. And I already did this a second ago, but let me just show you. I'm going to remove what I did and kind of show you from scratch if you were doing it point and click style. So system missing is still system missing. A 5 becomes 1. I just happen to know the scale is 1 to 5. If it was 7, 1 to 7, you'd go 7 equals 1, 6 equals 2. But so what we're doing is we're just flipping the direction of the scale so that all the items mean the same thing. 1, 5. Okay. Paste. Okay, so let's go back to our syntax. I like to move the recoding up first because if you're doing this on a new data set, you could just run all your recoding first, run all your reliability second, and then in a minute we'll create the code to create mean scores. Okay, so after I run this, okay, everything went okay, no errors. Now when I rerun reliability for gratitude, look, now it's better, 0.84, that's excellent. If we look at the item correlations, no negatives, the item total correlations, no negatives, this is good. So let me say a couple of more things about just kind of checking the scoring. So I knew that both of these scales, I was going to only score a total score for all of the items, but sometimes a scale actually has 2 subscales within it, and the only way you would know that is if someone else gave you their syntax and kind of told you how it was scored, or if you just looked up the original article where the scale was published. It always tells you how to score it there. So that's one of the challenging parts is you certainly have to have knowledge about the scale to know how it's scored. And I just picked 2 that are easy because I knew that they're only 1 subscale, but I can show you a few even within this data set that I know have more than 1 subscale. So this ethnic identity scale has 3. And I don't remember how to score it, so if I was going to score it again, I would have to look at my prior syntax where I'd looked it up somewhere and copy that, or I'd have to go back to the original article. To find the original article, what I usually do is I'll copy one or 2 of the items and do a Google search, and usually that will help me kind of narrow in on what the first article was that did the scale development for that scale, and I'll pull that article and look within it to see how to score it. Okay, so the final step is creating a mean score, and so you name the variable. I'm going to call this, the first one, religious commitment mean, parentheses, and I just happen to know this is how you give the command to create a mean. So you just type each item and separate it by commas, and then end with a comma. Hit paste. Oh, nice. Okay. So once you have this syntax and you know how to tell the program what to do, next time, and I'll actually just use the reliability code and then delete the top part. Compute gratitude equals, okay, what's next? Mean, parentheses, and then each variable separated by a comma. So I've already got these in here. End comma, period. You see that? And then I need an execute command. So if I hit play on these two, it ought to create a new variable at the end of the data set. I think I'd run this before, so I'm going to delete these so you just kind of see what it does. So when I hit play, it ought to, so everything went okay, no errors, and here these two variables are at the end of the data set. If you click here, it shows you what it ran for us. So this took an average of all 10, this took an average of all 6. So anyway, that's it. To finish the rest of the data set, we would just go through for all the other variables and do the same thing. So for example, this is the big 5 inventory. There are 5 subscales in this. So we'd have to kind of go through and make sure that we know which items are on each subscale and take the reliability. Reverse code any items, check the reliability again, and then once we know that we've got everything in the right direction, we can create the syntax for the creating the mean scores. Then you go on to the next one, intellectual humility, do the same thing, and you just kind of work your way through the rest of the data set. The only trick I can offer you is this takes quite a while the first time you're using any new variables, but if you get efficient with it and you kind of keep your prior syntax, then the next time that say I do that 5-factor big 5 inventory, I don't have to re-look up the subscales, and it can be as quick as me copying and pasting my recoding, my reliability, and my computing from another syntax file, and just copying and pasting into the new one, and I can run it. It can get to be very quick, but the first time, my guess is the first time that you do a data set like this and you're not familiar with the scales, it could take a few hours to kind of finish everything, but you get quicker and quicker. I mean, I would say now I could probably recode this one in maybe 30 minutes or so, because I have a lot of this stuff written. So, all right, thanks, bye.